Hi, welcome back to my grade 11 physics tutorials. This video is going to be on unit conversions using the unit cancellation method. So the basic point of the unit cancellation method is we use algebra, we use fractions of units to cancel units out. So an example would be if I had 30 meters and I wanted to convert that into centimeters. What I'm going to do is I'm going to multiply this by 1. Anytime you multiply something by 1, it doesn't actually change its value. However, it can change its representation. Here's the conversion I'm going to use. We know that 1 meter is equal to 100 centimeters. Now, if I want to cancel meters in this equation, then I have to divide by meters. So what I'm going to do is I'm going to divide both sides of this equation, by meters. When I do that, I get 1 on one side and 100 centimeters per meter on the other. So if I take this, I can call this 1. This is equal to 1. So I'm going to multiply my original number by 1. When I do that, meters divided by meters cancels out. And I multiply my original number by 100, so I've got 30 times 100, and the only unit left is centimeters, so I get 3,000 centimeters. That seems clunky with a simple conversion like this. What it does, though, is it lays out your conversions. If you have complicated conversions, like changing from imperial to metric or something like that, then this lays them all out and makes sure you don't miss anything. So a couple of examples. First example is the same kind of conversion, so I'll demonstrate it very quickly. Kilograms and grams. Kilograms is 1 kilogram is 1,000 grams. So in this case, we want to cancel the kilograms, so we're going to divide by kilograms. So we get 1 equals 1,000 grams over 1 kilogram. Now, if we multiply this original equation, let's make that a times there instead, by that conversion, which is equal to 1, doesn't change anything. We've got kilograms divided by kilograms, we're left with grams, and we get 1230 grams. So you can try the next two on your own, and I'll write in the answers so you can check. Remember, you can pause or rewind the video at any time. I'm not there to be upset. So, seconds to milliseconds, the answer is going to be 27.6 milliseconds is the answer. 555 millimeters to centimeters is going to be 55.5 centimeters. And gigabytes to megabytes, that's going to be 1,000 megabytes. Now the next one's a little more complicated. The next one talks about areas. At areas, we've got units squared. It looks complicated, but this is where our unit cancellation method can actually help a little bit. Because what we're going to do, when we have squared, we're just going to pretend it says megameters times megameters. In other words, we have to cancel out the megameters twice. Now we know that 1 megameter is 10 to the 6 meters, and 1 kilometer is 10 to the 3. So the ratio between the two is 1,000 or 10 to the 3. So instead of that, I'm going to write 1 megameter is 1,000 kilometers, or 10 to the 3 we can write as well. I'll write it as 10 to the 3 later. So the conversion, we're trying to divide by megameters to cancel those megameters right there. So 1,000 kilometers over 1 megameter. That's a horrible M. I'm sure you can figure it out. So let's write that out underneath here. 3.456 times 10 to the negative 5 megameter. Convert once. That's 10 to the 3 kilometers per megameter. That gets rid of 1. Convert a second time to get rid of the other one. Do a quick check of your cancellations. Megameter of megameter, megameter of megameter. You're left with kilometer times kilometer, which is kilometers squared. So we have 3.456 times 10 to the negative 5 times 10 to the 3 times 10 to the 3 kilometers squared, which is going to be 3.456 kilometers squared. You can look over that again if you want to. Next, I'd like you to try this one and see what you get for an answer. All right, I'm going to do this one quickly in my head and see if I get it right. You guys can check me. Micrometers and nanometers, that's a factor of 1,000. So we're going from a bigger to a smaller. So it's going to be dividing by 1,000 3 times. Yeah. So it's going to be 0.8467 divided by 1,000. So it's 10 to the divided by a billion. Sorry, 10 to the power of 9. Now, the only problem we have is we have to convert to scientific notation. So 8.467, I multiplied by 10, so I have to divide by 10. There's our answer. Nanometers cubed. So you can check your work on that. If you disagree with me, let's chat in the morning. All right, quick run through on algebra. Here's your conversion. You can try and do this conversion for tomorrow. Standard soccer field, 100 meters long, so you have to convert meters to soccer fields. You're going to use this equation, distance equals speed times time. Distance has to be in soccer fields. Speed of light is going to be 3.0 times 10 to the 8 meters per second. And the time is going to be 1 year. So when you lay this out and you're trying to do your cancellations, you've got to turn your meters into soccer fields, and somehow you've got to make your years and seconds cancel. So give that a try. See if you can solve that for tomorrow. All right, algebra. 4 rules I have for algebra. First thing, when you're doing algebra, you're rearranging variables that represent information, that represent values, which you either know or you don't know. In one case, hopefully only one, you're trying to find that variable. And the rest of them, you know. So what you're going to try and do is whatever you're solving for, whatever information you're trying to get as your answer, you put that on the left and get information, variables that represent values you know on the right. So that's the first rule. The second rule, when you're trying to do this, you're basically going to operate on the equations, on the expressions, by working Bedmas backwards. Hopefully I'll give you a chance to see that in the example. Simplify it one step at a time. Don't try to take shortcuts. If you should have completed grade 10 math before you came here, you should know how to do that, but we'll do it in a minute. And what you do on the big rules of algebra, what you do on one side, you do to the whole side, all of that side, and what you do to one side, you do to both. So here's our example. In this case, we're asked to solve for x. So we have an x term here, we have an x term here. So I'm going to go through this step by step, and you can follow along as we go. So the first thing, Bedmas is brackets, right? First thing in Bedmas is brackets. And when we have a division like this, that 4 is on both sides. So what we're going to do is we're going to multiply both sides times 4. So I'm going to put a times 4 over here, I'm going to put a times 4 over here. Now when you do that, those two 4's cancel. They're gone. So our next line is going to be zx plus 5 equals 3y squared minus xy plus 5. Let's keep going. Trying to get the x terms all on one side. We want to get x on the left side because that's the one we're trying to find. So this one's already there. This one's got to move. Now this one is being subtracted from the right side. So to get rid of it, we need to add it. We add it to the whole side, but we also have to add it to the other side. So our new line now, one step further, is going to be xy plus zx plus 5 equals 3y squared, and that negative xy is gone, so plus 5. Awesome. Now, when you look at this expression, we have something here we don't want there. So we're going to take it out. Now it's added, so we're going to subtract it. I'm going to add a negative to make it, it's a little confusing, but I've got plus 5 here, minus 5 here, so that should cancel. And then I'm going to do the same thing on the other side, minus 5. Well, that's working out nicely, isn't it? So the line we have next, 5 and the 5 are going to cancel on the left side. X, y plus zx equals 3y squared, and plus 5 minus 5 cancels. This is where we are. Next step, we need to get rid of the things that aren't x on the left. So what we're going to do is we're going to try to get this whole thing into one x and the rest of an expression. And the way we can do that is by factoring. Because both of these terms have an x, we can factor the x out like this. Now we have x by itself, kind of, except we still have to get rid of what it's multiplied by. Now it's multiplied by y plus z, so we're going to divide by y plus z. And really, if you're going to divide the whole side. But if you're going to divide both sides. That's going to leave us with, that cancels, and we have x equals 3y squared over y plus z. That is how algebra is going to work. If you can do that, algebra should not be a problem. And I strongly recommend, in the 7-step method that I've taught you, I strongly recommend algebra first. Get the equation to this form, what you want on the left, what you know on the right, and then plug the numbers in. Thanks for watching.